Hello folks, welcome to our TCL Global YouTube channel. This is the project video series from us where we are providing a short demonstration on the projects listed on our website. In this video, we'll give demo on project number ESI0055 Baby Stress Monitoring System. This is a bit bigger project and can be used as a good undergraduate final year project. To start with the video, we are showing a brief block diagram of the project where our transmitter includes a microcontroller with a camera and it streams the video of the baby using Wi-Fi. We can watch the video stream through a web server or in an app. There is another microcontroller with a microphone which can notify the parents with an alarm created by the buzzer in RX section when the baby is in distress. This system is similar to the fire alarm system, so whenever the baby will cry, the alarm can be run in whole house like a fire alarm. The TX and RX are communicating through RF transceiver. The primary reason for using two separate microcontrollers in TX is that we noticed if we use the same microcontroller for both camera and microphone, then the video streaming gets either slow or interrupted. As I mentioned, you can find a list of our projects in our webpage. In TX, for first microcontroller, we used Freenove ESP32 Wrover microcontroller board. Some key features of this microcontroller are it has 32-bit ESP32 Wrover B chip. It has 8 MB PSRAM. Pseudo-static RAM or PSRAM can help to increase the size of SRAM if necessary. Basically, you are getting more RAM, which are sometimes slower than the main RAM. However, it uses some of the pins of ESP32, which reduces the number of pins you can use. Moving on, it also includes built-in Wi-Fi module in the evaluation board. It also includes built-in Bluetooth module in the evaluation board, which we will use in our future demos. It has 12-bit ADC. Finally, one key thing to select this microcontroller is it has an onboard OV2640 2 megapixel camera. So we'll use this camera in this project to monitor the baby. Second microcontroller is Arduino Nano Every. It is used in both TX and RX. Some key features are it uses Atmega 328P as core processor. It has 10-bit ADC. It has PWM. It is a smaller form factor and it is also very easy to use. Now microphone sensor or sound detector can be used as analog or digital sensors. You can see some examples of commercial microphone sensors here. So these are mostly analog sensor with an option to provide digital output. So this includes a microphone, an amplifier, and a comparator in case you need digital output. Sometimes you must need to adjust the sensitivity of these devices to get proper performance. For the first two sensors given here, you must have to adjust the sensitivity. Sometimes they come with zero sensitivity adjusted and you can misunderstand that the device is not working. In this project, we are using the middle device. As wireless transceiver, we are using NRF24L01. It can achieve TX and RX distance of 800 meter to 1 kilometer. So we can use it in any part of our home to get the distress signal from the baby to any other parts of the home. It uses 2.4 GHz license-free ISM band. Also, it uses SPI communication protocol. and its baud rate range is 250 kbps to 2 mbps, and its channel range is up to 125 channels. This means we can use 125 NRF24s together to make any kind of communication, which is a very big benefit of using this device. We talked about buzzer in our previous project video. Link of that video can be found above or in the description. We'll use active buzzer in this project. As we already discussed this part in our previous video, so we'll skip this part for this video. Now moving into the main project, as I mentioned, we are using two microcontrollers in the TX section. First, ESP32 is being used with the OV2640 built-in camera. We also included indicator LED to see if the device is on or off. Next in TX, we have Arduino Nano Every with microphone and NRF24 as transmitter. So now if we turn on the TX device, the RGB LED will be on. And if there is a baby around, we can stream the baby's video through Wi-Fi. We can watch the video in a PC or laptop using web server with a dedicated IP address, or we can watch it in our phone using ESP32 Cam app, which is freely available in the App Store. Now if a baby is around, then the microphone can keep monitoring baby's voice using ADC in Arduino Nano Every. Now if the baby starts crying, then it will be identified by using microphone sensor, and the TX Arduino Nano Every will send the distress signal to RX by using NRF24L01 transceiver. The RX will then start the buzzing sound all around the home. You can also see the baby is stressing in the camera. There is also a RGB LED indicator is connected to RX system to just show if the system is on or off. Before going ahead, we would like to ask you to subscribe to the channel if you are benefited from our content. Also click the ring bell to get notification whenever our new video will be released. Stats show more than 50% of our viewers didn't subscribe to our channel. So please subscribe and help us to grow our channel so that we can provide much more quality contents. Now we'll move to the demonstration part of the project. To start the demo, here we have the TX circuit. So you can see the camera here in the ESP32 board, and we have the microphone here which is connected with the Arduino Nano Every board. So we kept a bit of distance between this microphone sensor and the other ESP32 board, because ESP32 board has Wi-Fi, and when we are running both of these together, there was some noise going on and we are not getting proper output from the microphone. So we had to add a bit of extra long wire to keep it separate. So now if we turn this device on, so we have a on-off switch here, you can see, and we also have a power management system here with the battery. So we'll not discuss the power management system in this video. So if we turn the power on, and you can see the RGB LED is flashing. It will flash blue 3 times and then it goes green. So it means the system is now on. and the camera is working. We also have two LEDs here. These are some high power white LEDs. So this can give better view in the night to the camera. So we'll mainly demonstrate this project in the web server. You can also try with the ESP32 cam app in your phone. It's very easy. You'll just have to add the IP address in the app and it should start working. So you can see here, when the camera was not on or ESP32 board was off, so the web server page was not opening. So now if I refresh the page, you can see the page is now open and is giving us a selection window where you can select the parameters of the camera output. So now if you press start stream, it will start streaming the video here. So you can see my hand here. So the camera is now working perfectly fine and is streaming the image and it's streaming through Wi-Fi in our home. So this is the TX system which is working fine. Now this is the RX system. We will turn on the RX and we'll see how it works. So the RX also has a on-off switch here. You can see the RF switch. It has the buzzer. We also kept this LED light here to just see that if the system is on or off. So now it has the power management system and the battery. So if we turn on, you can see again the blue LED will flash 3 times and the green light is on. It means the system is working. Now let me first turn it off, because like you saw that whenever I was talking, the buzzer was making the sound, the buzzing sound. So now again we'll turn it on and we'll test this system. So you'll see, like when I don't talk or do anything, there is no buzzing sound, but whenever I'll talk, the buzzer will be on. So the buzz, it means whenever the baby will cry, the buzzer will be on. So you can make multiple of these and keep it around your house to see if to monitor the stress of the baby. So now I'll just turn this on and I'll test this system. Hello. Hello. So you saw that the TX and RX systems are working fine. The camera is streaming, and whenever there is a noise or if there is any kind of sound, the TX is notifying the RX to set up the buzzer on. Before ending the demo, I would like to discuss two things. First thing is, we also struggled when we first used the sound sensors. So if you feel you are facing trouble with this, then we can make a separate video to discuss how to use it. Second thing is, we are planning to make a tutorial video on how you can power different microcontrollers with lithium ion rechargeable batteries and a battery management system. So we didn't discuss this in this video. We also didn't find a good tutorial on this. So please add more likes to this video to motivate us to make a video on that. So this is the end of the demonstration. So this is the end of the video. Please contact us if you need help with the circuit diagram of this project or support with the coding part. As I mentioned, you can find out the list of our projects in our website. Please subscribe to our channel for more videos like this. We'd like to thank those who already subscribed and helping us to grow our channel. Add likes and comments and give us suggestion of what kind of video you want us to make. Follow us on LinkedIn, Twitter or X and in Facebook. Thank you for watching. See you next time.